here to give my final presentation about PFAS testing. Here is the catalog of my final presentation. First, I'll introduce the method, and then compare old and new method, and finally do the data analysis. I actually prepared video like in YouTube talking about PFAS, but it's not working, so I'm going to introduce by myself. So PFAS is a man-made forever chemical which has the properties of environmental persistence. Some are hydrophobic, lipophobic, and resistant to heat, stain, and degradation. If it is in our daily life, we can intake it by drinking, eating, and some cleansing form. It will ultimately accumulate in human body and toxic to human and other organisms. Approximately, there are 4,000 to 10,000 PFAS compounds have been investigated. So I'm going to talk about the method. First is extraction, then sample loading, afterward is elution. So before doing all works, we have to do the preparation work first. We have to clean our connectors and buy methanol 5,000 and then sonication and then store it, prevent the contamination. And then we have to also prepare the solvent used in extraction, conditioning, sample loading, and elution by following the preparation sheet over there. And we also have to prepare one set, mostly one set of 15 ml PP tube, which mark as blue and red marks. We also have to do the conditioning of OIS wax or inlet subcutary and GC column, which is a new method introduced to decolorize water, decolorize some solvent color. And each wax column, usually we got recovery and samples, sometimes blank. And we have to add 4 milliliter of 0.1 ammonia methanol first, and then 4 milliliter of methanol 5,000. Finally, we have to add 4 milliliter of pure water. For GC column, we have to only add 0.1% ammonia methanol. We have to do it first by ourselves individually, which is time causing, but afterward, this machine has been introduced to help us to do it, and it saves time. And finally, we have to prepare 2 sets of 15 milliliter PP tube, also marked as blue and red. After that, we can start off our experiment. First, we have to weight 5-gram sample each in the PP tube with black marks, and then we have to spike label standard internal to every sample, but native standard internal standard to recovery sample. After that, we have to add solvent, depends on which sample are we determining, and usually it's 0.5% ammonia methanol and acetonitrile. Sometimes when we are doing water experiments, we have to use millicube. After that, we have to shake using the machine over there, and first time is 30 minutes, second time is 10 minutes, and third time is 10 minutes. After that, we have to vertex, every time we want to make something well, and then have to centrifuge the tube for 10 minutes. And then transfer it to the new tubes marked in blue. And then we have to repeat this process 3 times, and then to get the solution in the blue tube. And then we can centrifuge it and transfer it to the red marks new tube. And we have to check the color code to record down in the sheet also. After that, we have to do the nitrogen evaporation to concentrate the solution to 5 milliliter. But it is only for the old method because we got 13 milliliter in total. So we have to concentrate to 5 milliliter to add pure water and acetic acid. But for the new method, we can skip, omitted this part. So we can check the pH here to check if it's acidic or not. here are some pictures. We are weighting the sample to precise 5 grams, and then we are doing the extraction process here, pouring the solution and centrifuge. For sample loading parts, we have to pour the sample solution to cartridge to do the sample loading first, and then we have to load it with 4 milliliters of pure water and buffer. Notice that it should be transferred to the PP tube first and then cartridge, and then centrifuge the cartridge for 5 minutes. And then validating, like doing work here for the conditioning. And for the elution part, we first have to elute with 5 milliliters of 0.1 ammonia methanol by setting up manifold. Like this is the manifold and GC column, cartridge, and we have to check the color code because we have GC column introduced there, so it's always decolorized. And we have to undergo the nitrogen evaporation to 1 milliliter. It usually takes 40 to 50 minutes. After that, we have to adjust it to exact 1 milliliter by methanol 5000 and then vertex it to mix it well, and then we have to put it into 100 microliter vial here to send it to the analysis room. Yeah, here are the photo. I'm doing the elution and then the nitrogen flow, and then we are doing the adjusting parts. For the test subject, I can divide into 2 main parts. First, we are doing the soil water parts. We have followed the Minister of the Environment Japan to do the suspended solid in water sample. And also, we have determined about the drinking water avion, like soil, water, and solvent. These 2 sets of samples were being conducted at the same time. For vegetables, we have conducted tomatoes, Japanese mustard, spinach, which is komazuna, and like cucumber, potato, and rice. But however, for potato and rice, we are not included in data analysis, so we are not going to talk about it now. Of course, we will harvest our samples in the dependent field and our experimental field here. We can see like we're happy to cut the cucumber and then crush it into small pieces. And then yeah, potato and spinach, and we are crushing the tomato over there. Here are the comparison of old and new method, which like introduced by Yusan already. Is like for the simplified one is like much better results you can get. Let me introduce what is old method first. It is the extraction procedure differences between old and new. For old one, it will add 10 milliliter each of the solvent each time, and will undergo nitrogen concentration before adding pure water and acetic acid. So this step may take 4 to 5 hours, so it will cause some sample loss and maybe some human error when we are doing that. And for the new method, since we are doing it just like 8 milliliter and then 4 milliliter twice, we can skip that nitrogen concentration process. And since it's less procedure, it will save more time and prevent sample loss and human error. Yeah, here is the data sheet we get after we finish one experiment. And I have the yellow highlight here shows that these are the important element of PFAS, and we are looking into it. Yellow highlight PFAS element is really resistant to degradation, which can be easier detected by doing the analysis, the MS here, and then it's very long lasting because it is a breakdown product of longer chain PFAS, which is relatively stable. But it will accumulate in vegetable grown in contaminated soil because it has really strong CF bonds, which resist to break down. Especially for PFOA and PFOS, it is like raised the concern about having the bad effects on human and wildlife. So this yellow highlight PFAS element is really important element in analyzing. We can divide the PFAS into two main parts. First one is sulfonates, and the other one is carboxylates. For sulfonates, it has stronger acidity, higher environmental persistence, and higher bioaccumulation potential. For the recovery rates that will like underneath the data sheet, we can check it by the accuracy, efficiency, potential error, liability, all this can be determined. First, let me introduce the data of water. We have done it right before at the beginning of our internship. For the PFAS content, actually blank should be 0, as you can see, but however, it's like just similar to the sample I made, so it's not satisfying. And for the recovery, just these are the calculations, so we'll turn some having the 20 like value concentration of recovery. And the potential reason of having such abnormal high concentration of the PFBA compared to other data set made by Mr. Nagano-san and Yu-san is because we have the sample contamination inside, and the PFBA's property is like in the water samples with lower pH, it will have higher concentration of PFBA. And when the acidity increase, PFBA transfer from water into air, which will affect its stability.